Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. Today we're going to cover strength of materials N6. The topic of this tutorial is deflection of beams, example 3.4. Let's get straight into it. Okay, this is a simply supported beam. It's a simply supported beam that has a UDL over its full length. The UDL, UDL stands for uniformly distributed load. It's 12 kilonewtons per meter. Now, also we have a point load. We have two supports. It's simply supported. And we have another support that is 2 meters. That is 2 meters from the end of the beam. And that's 4 meters. Right. And this is 80 kilonewtons. Okay. So, our question states, a simply supported beam with a length of 6 meters supports a point load of 80 kilonewtons, 2 meters from one support. The weight of the beam is 12 kilonewtons per meter. So that's what I mean by UDL, is the weight of the beam itself. So, what we need to calculate is 3 things. We need to calculate the reaction at the supports, the maximum moment of resistance of the beam, and select a suitable I section to be used if the maximum allowable stress is 120 megapascals for the beam. Okay, first things first is what we're going to do is calculate the supports. So, this is LR, and that's RR. Now, we're going to calculate our reactions. Now, go from R. Anti-clockwise. Anti-clockwise is going this way, and our clockwise is going that way. So, we're going to take a moment about the right-hand reaction. So, 6 LR is equal to, now this is going in the opposite direction. So, now we are working with 4 times 80 plus 12 times 6 times 6 over 2. That's how a full length UDL works. Because you take the full length of the UDL divided by half of the UDL. So multiplied by half the UDL. So you take the whole UDL and then you divide and then you multiply that by half the UDL. Okay. So what we have now is for LR is 320 plus 216, 6, and LR is 320 plus 216 divided by 6 equals LR. Now LR will be, let's do the calculation quickly, is 320 plus 216 divided by 6. We're left with 89,33. 89,33 recurring. Okay, now LR is equal to 89,33 recurring. Now, all we have to do is state the going down is equal to the going up in order to get RR. We don't have to go through the whole rigmarole calculation again. So all we're going to do is RR is LR plus RR equals the down. So what is going down? What are the forces going down? 80 plus 12 times 6. That is what's going down. And we've got 89,33 plus RR. So, what we need now is 80 plus bracket 12 times 6. 152 exactly minus 89,33. 152 minus 89,33. Okay, we have RR equals 62,67. 62,67. Now what we're going to do is make ourselves a shear force diagram. Now we're going to make ourselves a shear force diagram. So how a shear force diagram works is that we're going to draw some lines. Okay. 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 Now we have our lines. Now we're going to have a 0 line. Now we're going to have a line of 0. 0, 0. Now we need our calculators for this. Okay. Because this is how it works. This is how it'll work. It'll work by going at each line. We will go either up or down. So LR is 89 0.33 up. So right there is 89,33. Right. Now it goes down. Now it's going to go down by 2 times 12, so 24. So 89,33 minus 24. Equals 65,33. So that'll come down to here. 65,33. Now we're going to go down by 80. Minus 80 equals, that's a negative. So that's negative 14,67. Now we're going to go down again. Now 4 times 12. 4 12s are 48. So minus 48. And that gives us 62,67 negative. Negative 62,67. Then at the top of the reaction, it comes back up to 0. At the top of the reaction, it comes back up to 0. So right now we know that all our calculations are in fact. So now we know all our calculations are in fact correct. So let me just reiterate what I did. First, I went up. 89,33. I went up. Then I went down. Then I went down 24 to get to this. Then I went down 80. Then I went down 48. And then I went back up 62,67. Okay. Now, what's necessary from this, from our shear force diagram, what's necessary from this is we might have to get a value from it. So, max, M max. So the position of the maximum moment of resistance is at the point load. To determine the maximum moment of resistance, take moments about the point load to the left of the beam. So, M max is LR times 2 minus the weight times A over 2. Okay, so what we know is this equals A and that equals B. So that's the length between each section. So that's a length. So what we have now is LR, which is 89,33 times 2 minus W, which is the weight of the beam, which is 12, times 2 times 2 over 2. So equals 89,33 times 2 equals 178,66 minus 24. Minus 24. And that gives us 154,66. So M max is equal to 154,66. So equals 154,66. kilonewton meters. Okay. Okay, now to calculate the I section of the beam needed, right, we have our moment, we have our maximum moment, so now that is going to be our next sum. So, now we need to calculate the I-beam, calculate a suitable I-section to be used if the maximum allowable stress is 120 megapascals. So, stress is equal to 120 times 10 to the 6. Okay. So, alright, our next question is we need to find a suitable I-beam. So ZE is equal to capital M over stress. So what we have is 154,66 times 10 to the 3 all over 120 times 10 to the 6 equals 1288,83 times 10 to the minus 6 meters cubed. Okay, now you've got to check your I-beam tables. Yeah, we need ZE. So ZE is going to be 1288, and that would be the closest one to that. The closest one to that closest flange, parallel flange, is 457 times 91191 times 67,1 kg per meter. And that is our final answer. That is our final answer. That is what this I-beam, that you will take this gauge of I-beam for this application. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.